Hey y'all, this is Jeff. I'm here today to show you how to work with Jukebox Diffusion to transform beats or other loops you may be working on in your music productions, and using AI, make them into something a bit different that may help you explore new sonic possibilities, make new loops. So specifically in this video, I will be taking this beat and transforming it into something a bit different, maybe like this. Cool, so let's jump in. The first thing you got to do is obviously create the beat or loop that you're hoping to work with and prime it for use in Jukebox Diffusion. So due to the nature of Jukebox Diffusion and how it generates new audio, it's quite important actually that the loop or the beat that you have in question has a decent amount of bass frequency, because we're going to be extracting the BPM, the actual transients from the kicks and the bass line to establish harmonic content that the AI is then going to take and transform into something new. So what I have here is I have 3 tracks here. It's just something that I was messing with one night. I have a beat loop from my MC505 Groovebox that I've just recorded in here, a bass line, and then a synth in the background that kind of gives it the harmonic quality that I want it to follow. And I've done a few things here. I've kind of cleaned up the beat a little bit. I'll show you. I just kind of threw an EQ on it. The EQ is just doing a little bit of a bump here around 160, and I've lowered a little bit of the bass content just because it was a little too bassy for my taste. And then I've kind of cut out the mids here to make room for the bass line and the chords in the background. So that's just to kind of mix them together and make them sound a little bit better. And then on the entire master channel, I've added a limiter, and this is actually kind of an important point here. If you're going to be using a beat or a loop of your own and you'd like Jukebox Diffusion to mess with it, the Jukebox Diffusion model was actually trained on fully mastered tracks. So if you give it something that isn't fully mastered, or at least limited to some extent to sound like it's mastered, it's a bit too quiet for the model, and it starts to interpret it as maybe something that doesn't have a beat, or maybe something that it doesn't quite expect. And it gives you a little bit more ambient, kind of like droney sort of outputs. So if you'd like it to keep the beat, if you would like to keep the bass line, then I would suggest throwing a limiter on there at the end. I've just kind of smashed it a little bit. And yeah, so the overall, what I've output from Bitwig is this. Okay, great. So now we have the clips that we're going to be using to create new and interesting ideas. The next thing that we're going to need is we're going to need something for Jukebox Diffusion to listen to as inspiration. This is a little bit of I would say a hand wavy kind of like inspiration. So I will show you 2 different examples. I have a techno track from Scuba that is basically just beat and bass, and this is what it sounds like. So you can tell from listening to that there's really just some hi-hats, there's a bass line in the background, and then there's some noise going on in sort of the mid-high frequencies, but no other real like content in terms of like vocals or other instruments or anything like that. And then obviously the kick as well. We're going to contrast that with a different track that we're going to have Jukebox Diffusion listen to and kind of shape your input audio accordingly. Here I have a clip from a Dua Lipa song. So you can tell that's much different. There's obviously a lot of instrumentation going on. There is a female vocal. And so we're going to hope that by using that audio as context, the AI algorithm will take your beat and maybe add a little bit of like female vocals here and there. So really quickly, before we dive into these things, I will take a moment just to note the length of the clips. Over here, like we said, we have the input audio that we're going to have the algorithm change for you. And then over here, we have the context or the songs that they're listening to as inspiration. You'll notice that the 2 songs that I have as inspiration are quite short. They're actually only 5 seconds. and that is done on purpose. The audio that you're going to use as context is going to get clipped to around 5 seconds anyway, because that's just what the model expects. So to make sure that you have the part of the song that you really want it to listen to, I would make sure that you clip them yourselves and clip them around 5 seconds. If you don't, what it will do is it will just take the last 5 seconds of the audio that you provided, and then that's the clip that it's going to listen to as inspiration for transforming your input audio. Now, the input audio choosing length here is also a little bit important. I'll get into that in a little bit, but just so you keep this in the back of your mind, each of these clips for me are around 8.7 seconds. It's rounding up here to 9. So yeah, I'll explain why that's important. Okay, so I have uploaded all the files that we've created here that we're going to need for Jukebox Diffusion to use in my Google Drive. It is in my drive, a folder called AI, and then I made a folder called Init Audio, and here's my demo folder. And so they're in Google Drive, and that's going to be important because you need them in Google Drive for Google CoLab to access them. Yeah, here they are. And now let's move over to the actual CoLab itself. Here's the Google CoLab. I'm going to connect here. You can use a T4 for this, is perfectly fine. All right, we're going to connect to Google Drive. It's going to take a second. All right, now go down to the next cell and install everything. Okay, sweet. So everything's installed now. So we're going to move down to the settings section, and I'll walk through what all of these do. First, project name. This is just going to be the name of the directory that the files show up in. So I'm going to name this JBD demo. So now all my files are going to show up in a directory called JBD demo. Okay, so context audio. This is the audio, what you want the Jukebox Diffusion model to listen to. So we picked a couple tracks, one from Dua Lipa and one from Scuba. So I'm going to go ahead and find those. All right, so we got the Scuba or scb.wave. I'm going to copy that path. I'm going to throw it in here. And so this is the audio that is going to influence where the algorithm takes your loop. Underneath, length in seconds. This is really only used if you're going to be generating from scratch. The model can generate just a random new clips, tracks, whatever you want. But in this demo, what I'm going to be showing you is I'm going to be showing you how to take an input track. So the length is actually going to be taken from the length of whatever you input. So this is, you don't really have to worry about this right now. The next section is where you're going to save your files. So this is just saying that it's going to be in content, which is the parent drive of the Google CoLab. Drive is what we connected, my drive here, AI, and then there's a folder called JBDiff where all of the results are going to be. Underneath the upsampling level, this is important just for a trade-off of how long it takes to generate samples versus what the end quality is going to be. So basically, if we go up here, there is a JBDiff quick guide, which I've loaded here. And in this quick guide, it gives you an explanation of what's actually going on under the hood of Jukebox Diffusion. So what Jukebox Diffusion is actually doing is it starts at a bottom level and it generates information at that level. So this level is the most compressed in terms of raw audio. So it represents the most audio. So a window length here represents more than a window length at the middle level and more than at the top level. You don't have to worry about this too much. Just remember that there's 3 levels before it gets upsampled to your final audio, and it starts from the bottom and goes to the top. So you're always going to use this bottom level. This is the first level that it generates at. It has a window and it generates there, and then it's going to pass it up to get upsampled. So you have 2 layers of upsampling here. There is the middle level and then there's the top level. So based on what quality and how long you want your generation to take, you can choose to either use only this middle level as an upsampler, both of these as an upsampler, or just not use an upsampler at all. So the trade-off here is actually that if you generate at this bottom level, because it's the most compressed, you're going to get like a lot of artifacts. I can actually show you what that kind of sounds like. Here's an example of the bottom level. You hear how there's like a lot of artifacts, especially in the high frequencies. That's because this bottom level, because it contains the most information in the biggest window of audio. What it is extrapolating or understanding is more kind of high level information, and especially low frequency information, bass and kick. This is because lower frequencies happen at a slower rate. So you can think of it as the algorithm at this level, because it has a bigger window, is actually picking up on those slower frequencies and kind of dismissing the high frequency information, which you can think of as more details. And because it's trying to retain as much information as possible, being super compressed, it's actually grabbing more of that low frequency information and dismissing the high frequency detail, which happens very, very quickly. And this is the nature of just compression at this level. If you think about it, if this window represents, 2 seconds of audio or something, things that happen really, really rapidly, like high frequencies, are going to kind of look a little bit more like noise at such a big window. Whereas things like low frequencies or locations of transients happen at such a low frequency that it's actually picking up on that information a little bit better and dismissing some of that high frequency information. Whereas at the middle and top levels, this compression level starts to pick up more on the high frequencies because it doesn't actually have such a high window that it can understand patterns of transients. Because if, let's say, this top level only representing 200 milliseconds or 500 milliseconds of audio, there's just not enough audio there and not enough repetitive nature for it to actually extrapolate the locations of transients, and those bass frequencies also aren't as obvious to it. So yeah, that's basically how you can think about this. Is the bottom level understands a little bit more kind of like meta information around like what things are present. Is there a presence of vocals? Is there a presence of guitar? Is there a presence of something else? Absence, presence, and then also locations of transients and bass frequencies. So as you use more of these upsamplers, what it's going to do is it's actually going to clean up those high frequencies that are really noisy in this bottom window before it passes it to dance diffusion, which is going to do our final upsampling. So the options here are high, middle, and low. Middle just uses the middle upsampler. Low doesn't use any upsampler. It just takes directly from the bottom level and gives it up to dance diffusion. And high uses the bottom, middle, and top layers. Now, as you can see, because this generates window by window, what's going to happen is the bottom layer is going to generate a window. And then for every bottom layer, if you're using the middle upsampler, we're going to have to generate 4 windows at the middle upsampler. And then if you use the top level upsampler, you're going to have to generate 4 more windows for every window of middle upsampler. So you can think of this in terms of, every single layer takes a little bit of time, and especially the top layer, because it passes it up to dance diffusion. The top layer window is going to be the length of time that dance diffusion has to generate as well. So if you're just using the middle upsampler, you're going to generate here, and you just generate 1 window at the bottom level. You're going to generate here, and then you're going to generate 4 windows here. And if each window takes around a minute, that means you're going to take around 4 minutes for a generation here. Whereas if you pass it up to the next level and you need 16, and each window takes around a minute, it's going to take you 16 minutes to generate the same sample. But using the top upsampler does increase fidelity, especially in the high frequencies, and makes it sound a little bit better. But I found the middle level to be a pretty good trade-off between quality and time. So we're going to keep this at middle, but just so you understand what that does. Okay, the next thing we're going to talk about is the Jukebox base layer diffusion parameters. There are 3 parameters here. There's a noise seed. So one of the things that I've found really fun about interacting with Jukebox Diffusion is keeping track of seeds. Seeds contain a lot of information and can steer generations in certain ways. So with the base layer, what we're talking about here, when you're talking about a seed, is it's going to listen to the context audio, and then in conjunction with the seed, it's going to come up with what you're going to generate. And so obviously here, like we talked about, that's going to be things like transient locations, bass frequencies, and then presence or absence of certain instruments. So this can tend to have a really cool effect if you keep track of seeds of like, oh, this seed always makes my bass sound a little bit more like an 808. That's what you're going to keep track of here. -1 is just going to give you a random seed. So I like to start off with -1s and kind of explore around, and then keep track of seeds and reuse them in strategic ways. Another thing that you can change is how the noise changes over time. So obviously we're going to generate a window, and then if you have another window to generate, you're going to use noise here, and then you're going to use noise here. So how does that noise change over time? There's a few different options. You can keep that noise constant. You can make it random every single time. There is a parameter called region where it will take the seed that you gave it, or the random seed, and then as you move forward in time, it will randomly perturb the random latent vector that is generating from in some sort of way. So region, it's going to keep an anchor. You can think of it kind of like a cloud. You're going to stay around that seed, and then you're going to randomly move around that seed in kind of like a cloud as you move around. So you can kind of keep it in the same area, but change it up, and that will make your generations change over time. The other option is walk. Walk works in terms of it just randomly perturbs the seed and then saves that seed as the new anchor every single time. So you can think of it as a random walk. It's going to make your generations move throughout time and not stay anchored to one specific area. The noise step size is how much you're going to move, and that is going to be somewhere between 0 and 1. Because we have constant here, it's really not going to make a difference, but you can kind of guide the model into how much you want the generation to change over time. I've found that the base layer, unless you're making super long generations up to like a minute or something like that, I generally just keep it at constant. So it kind of stays the same as the backbone for the generation, but you could experiment with obviously messing this up a lot and having it move a lot and see what happens. But I keep it at constant for the base layer. And to be clear, the base layer is here, this bottom level right here. Okay, great. So the next seed parameters that you have available to you are for dance diffusion. So dance diffusion, like I said, is our final upsampler in Jukebox Diffusion. And again, you can keep track of the noise seed. You can give the noise style and then give the step size. Dance diffusion is an unconditional model. So dance diffusion actually isn't going to listen to the input audio that you gave it. It's going to rely on the levels below it to kind of do the generation up to a certain point. And then it's going to take over and kind of just, well, first of all, it changes the mono audio of Jukebox into stereo. So it'll give you a nice stereo sort of signal at the end. And then also it's going to upsample it into a sonic space that has better high frequencies, more detail, more clarity. So this one is actually really important. I find changing the seeds and keeping track of the seeds here to be a lot more impactful on the overall kind of sound of what you're receiving, because it is doing all the detail and clarity. And also fine tuning how this changes over time is really important, because again, it's not listening to what came before it, like with Jukebox. It is instead just taking from the layers below it and adapting it in some sort of way. And the noise here is going to be the key way that you kind of give it information on what you want it to sound like. So I've saved some seeds that we're going to mess with here. The first seed that I'm going to put in is right here. And oops. And I'm going to use the noise style as walk. So this is going to continually change window by window. And the step size I use here is the default of 0.15 for this. The next parameter that you have is token multiplier. So token multiplier it's a bit of a more in-depth sort of parameter. It does have a really big effect on how fast your audio is going to change over time. There's a table here in this quick guide that gives you an idea of, at every single layer, given a token multiplier, how many seconds of audio that level represents. So keeping in mind the parameter of upsampler level, which what we have is middle, and then keeping in mind the default token multiplier of 4, we can get an idea of how quickly our music is going to change over time. So we have a token multiplier of 4. Our base layer is going to generate 8.916 seconds per window. And then our layer 1 is going to generate 2.229 seconds of audio per window. And our top layer is going to generate 0.557 or 557 milliseconds per window. Now, I've chosen to not use the top layer. So our only upsampling level is going to be this layer 1 right here. So what's going to end up happening is when I click generate, What it's going to first do is it's going to generate 8.916 seconds of audio, which conveniently is around the length of time of my input audio. I made a clip that is around 8 seconds long, so it will only have to generate one window of audio here at layer 2. Then it's going to pass it up and generate 4 windows of audio at layer 1, which is 2.229 seconds each. And then layer 1 is going to pass that. It's going to skip layer 0 and it's going to pass it directly up to Dance Diffusion. And then Dance Diffusion is going to mirror the window length of 2.229 and generate 2.229 seconds of final audio. So this is important because that means that at token multiplier 4, Dance Diffusion is going to generate a new window and change noise every 2.229 seconds. If you were to change this token multiplier to, let's say, 8, it would double the length of time before Dance Diffusion changes the noise on you. So we're just going to keep this for now. And then down here, this is the init audio, which is what we wanted. This is the point of the video, is to kind of change what we already have and make it different. So what I have here is I have this demo beat full. I'm going to copy that path, put it here. And the final parameter that we have, ignoring this for the moment, is init strength. So this is how closely do we want it to follow the input audio that we gave it. I have it set at 0.12, which I've found to be a pretty good mix of it stays true to the original harmonic content and the original locations of transients without changing it too much. If you move this down to, let's say, like 0.05 or something like that, it's going to change it quite dramatically and actually probably change where the transients are and things like that. So I'll do an example of that so you can see what that looks like. And obviously, if you go down to 0 here, it's not even going to use your input audio at all. It's really just going to generate from scratch. And then if you have it up, it's even at like 0.4 or 0.5, it stays pretty true to the original and doesn't change it all too much. So we're going to start with, I'll start with 0.1. Great, we have all the settings. I'm going to click there. And now we're going to generate our first clip. So as we talked about, it's only using levels 1 and 2. 2 is our bottom layer. So it's loading it right now. Loading level 1, which is our middle layer upsampler. It's giving you some information you don't really got to worry about. Okay, so now it's starting to generate. So what do we have here? We're sampling level 2 out of levels 2 and 1. Again, 2 is our bottom layer and 1 is our middle upsampler. It's saying it's sampling step 1 out of 1 steps on this level. So because I gave it input audio that is around 8 seconds, it only has to generate one window of audio again at token multiplier of 4 to generate 8.916 seconds of audio, and it's satisfied the constraint of generating 8 seconds of audio. So it's only going to do one step on this lower level, and then it's going to consequently do 4 steps on the layer above, and you'll see that. So now it's sampling on level 1 out of the 2 levels. It's not working. Oh my God. And you can see it's sampling step 1 out of 4 steps on this level. And then so it did the upsampling pretty quickly, actually. It only took like 3 seconds, and now it's passed it up to Dance Diffusion, and Dance Diffusion is generating your final audio output for this window. And that's going to take around a minute, you can see. So the way you can think about this is, okay, it generated the bottom level in around 33 seconds, and then it's going to take around a minute or a minute 10 to generate each of the 4 middle upsamplers at this window length. So that's going to be around 5 minutes to generate that 8 seconds of audio. Now, if you change the token multiplier, you could increase or decrease the top layer window, and then the windows might take less time. But then maybe the bottom layer takes, like if we had token multiplier of 1, it would take 4 windows at the bottom layer of 2.229 seconds each to reach that 8-second threshold. So it would generate 4 windows at the bottom layer, and then for each of those 4 windows, it would generate 557 milliseconds at the middle layer upsampler, which means that you might actually take less time at the top. Like each Dance Diffusion step might only take like 30 seconds, but now you're doing 16 times 30 seconds, which is around 8 minutes. So keeping in mind, and then obviously if you use the top layer as well, 4 and then 16 and then 64 at the top layer. And then if it's 30 seconds times 64, it's going to take you 32 minutes to generate 8 seconds of audio. So Messing around with these can give you, again, like I said, a trade-off between quality and amount of time it takes. And you can kind of experiment with these to understand how long it takes to generate. Now it's sampling the second step out of 4 on the middle upsampler level. It's doing dance diffusion. It's almost done with this, and then it'll move on. Okay, so we have finished the first generation. It's telling you the file location that you can find. To explain a little bit of the directories and why they're named that way, obviously we said that the directory where we want to store everything is content drive, my drive, AI, JBDiff, and then the project name. And then the 2 numbers that are following the project name are going to be the noise seed that was used for the bottom layer, which we chose as random. So it gave us this one as random. And then the noise seed used for dance diffusion. So if you'll recall, we put in a seed for dance diffusion, 4048492, and it saved it here so that we can always remember what seed we used. So let's go to that directory. Oh, there we go. Okay. So here's the directory right here. And inside this directory, the things that you're going to most be interested in are obviously the final audio.wave. This is what was finally output. But then the other wave files that are included here are the wave files that were generated at the bottom layer and the wave file that was generated at the middle upsampler level. So you can kind of get an idea for what was generated at that bottom layer versus what ended up in the final audio. And you can kind of tweak parameters to understand like what is dance diffusion controlling versus what is jukebox diffusion controlling. There's also videos here, and these videos will show you spectrograms over time. So if you're interested in that, you can kind of get an idea for what's happening in the frequency content. Okay, so let's listen to the final audio. Let's see what it did. Again, what it sounded like initially. And here's what we generated. Cool. So what it's doing is obviously it's taking inspiration from that context audio that we provided, which was this. Which you can see is very, very empty. And so what we've received in return is also pretty empty. It's also changed that chord there, which is really cool. And a little bit more spooky. Now, I will admit also that the seed that I chose, I've found to be a little bit more of an emptier seed. And so I'll show you an example of using a different seed that kind of contains different information for dance diffusion to use, and it'll change the output a little bit. So here is what was generated at the bottom level, just so we can inspect that a little bit. So you can see that the emptiness kind of started even at the bass level. There is a little bit of what sounds like kind of demonic voices in the background, but they're relatively muted compared to what I've heard in other examples. Also, something that's really interesting is if you'll remember from our initial beat, it's pretty consistent, and there's no kind of like double kick at the beginning, and this generated a double kick here, or like a triplet kick or something. So that actually showed up in our final audio too. Yeah, you hear that little like da 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 da. So that's new, but it stayed in time. It kind of did like a triplet thing, so that's pretty cool. Sick. If you want to inspect what the upsampler did, the upsamplers generally just take away a little bit of that high frequency noise. So instead, you hear how it's not really adding anything new, but it is kind of taking away some of that really like kind kind of gnarly, high frequency grating kind of sound. And that does help when we pass it up to Jukebox Diffusion, because then Jukebox Diffusion doesn't have a whole lot of high frequency content that it doesn't really know what to do with. I found if you go straight from the bottom layer up to Dance Diffusion, then it really tries to fill that kind of high frequency hiss with like hi-hats or something in a way that doesn't really sound too great, or like vinyl noise sometimes it does. So I always like using at least the middle upsampler. If you use the top upsampler, it would have made it even a little bit less harsh before I'd hand it up to Dance Diffusion, and that's why it increases in fidelity the more upsamplers you use. Cool. Okay, so that was one noise seed. I'm going to show you a different noise seed for Dance Diffusion. This one's pretty fun for me because this seed I have found contains information for including hi-hats, or sometimes like triplet snare kind of hits or something like that. Whereas the generation that we just did was a little bit more muted. This one is going to have a little bit more kind of like percussive highs going on. So literally exact same settings. I just changed the seed for Dance Diffusion, and let's generate that. Okay, let's see what the generation sounded like with the different Dance Diffusion seed. So yeah, it created a version of this that still sounds kind of like empty, like the scuba track. But the noise seed that we use for Dance Diffusion, like I said, I've found it has information for creating hi-hats and especially triplet patterns. And that's exactly what we hear here. Listen again. Compared to our original. You can hear there's none of that triplet pattern there, so it completely made that up. I love that. Cool. And we had a different seed for the bottom layer too, because I still have that set to random. So let's take a listen for what that sounded like. Cool. Yeah, you can tell it also did that kind of like weird triplet kick thing again, but I don't think that made it in the final audio. Or did that? Da, 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 da. Maybe that did make it. Yeah, let's hear. Yeah, I guess it kind of did. Interesting. Cool. So those are the two seeds I want to show you and the difference between seeds. Like I said, again, I've found seeds that have been able to consistently produce female vocals, no matter what the context audio is and no matter what the input audio it is. It just adds kind of like a female kind of thing. I've found different shouts, different instruments that are associated with different seeds. So it's really just a playground of exploration and then keeping track of what you find and what you like and associating it correctly to create something new. The next thing I wanted to show you was, again, we used a scuba track as the context audio and everything sounded pretty empty. Now what we're going to do is we're going to change the context audio to be a Dua Lipa track. I'm not where you left me at all. So we're going to try that and see how that changes things. My prediction is that we will get some female vocals showing up in our final track. But like I said, changing context audio can change things in very unexpected ways, hand-wavy ways. So it's always good to just experiment and see what's going on. So the first thing I will do is I will only change the context audio. I will keep the same seed that had the hi-hats in hopes that we get hi-hats again. All right, let's see what that sounds like with the new context audio. So again, our input is this bass loop that I printed out. And now it's listening to Dua Lipa instead of Scuba. For inspiration. All right, let's see what that did. Yeah, so you can tell there's vocals in there, which we did not have previously, which is pretty cool. The vocals are just kind of like stabs and weird, but yeah, they're there. Change that chord too, weird. All right, let's listen to the bottom layer, see what that did. Yeah, you can hear those vocals are in there from the bass layer. So the bass layer is what decided to put those vocals there. Sorry if I talked over that here. Listen again. And that chord change happened there too. So again, that bass layer is keeping track of presence, absence of certain parts, and then also harmonic content. And you can tell because we kept that same seed, it actually kept that same triplet pattern of the hi-hats as well too. Now we just have some vocals in there, whereas before we didn't. Okay, cool. Let me show you. We're gonna still keep that Dua Lipa. So I decided to go back to using the scuba example. I think the scuba example harmonically sits a little bit better because I'm gonna mess around with changing that seed back to a little bit more empty without the hi-hats. So we'll go back to that other seed we were working with for Dance Diffusion. And now what I'm going to do is I'm going to lower the init strength. So far we've kept pretty true to the transient locations and the bass lines and the harmonic content. I'm going to lower the init strength to 0.06. We're going to see what that does. Okay, let's check out what happened. So again, we loosened up the strength of the init audio. So we're allowing the bottom layer to imagine different harmonic content. So this is a init strength of 0.06. Yeah, so you see how it loosened up a little bit. So we don't have that consistent beat pattern anymore. There's parts where it actually took that beat out. And it's made things a little bit different. So let's listen to the bottom layer because this is the layer that actually was affected by this change. Yeah, so you can see at the beginning it kind of took out some of the beats and then it added some more beats at the end, and it's following a similar kind of pattern in the same chord progression. We threaded the needle quite well there, I think, where it's showcasing how it's changing some transients, but it's still keeping the overall idea of the chord progression pretty consistent. So again. Yeah, they kind of like come and go, and you can see they also added those vocals in, which is why it ended up in the final audio. Cool. All right, sweet. So now, so we've discussed changing the init strength does for the bottom layer. We've discussed what changing the seed does for Dance Diffusion. Changing the seed for the bass layer as well would change things up. I'm gonna actually take the seed that we just had so we can keep things pretty consistent, and I'm gonna change something new for you. So now instead of a random seed at the base layer, we're going to use the seed that we just generated because I kind of liked what it did. And now what I'm going to do is I'm going to change the init strength for the Dance Diffusion model. So that's not provided here. That's more of kind of like an advanced feature. I'll show you where that exists. It exists over here in this directory for Jukebox Diffusion. And there's a jbdiff sample v1.yaml file. And in this file, you will find up here in the sampling section, there are more there are more parameters for you to tweak if you want to, that are a little bit more advanced. So the way that you can think about this is, because it's a hierarchical latent diffusion model, every single one of these levels does diffusion and then passes up the generated audio at that compressed latent level to the layer above it to be recompressed and then diffused and then decompressed again and then recompressed, diffused, decompressed, all the way up to dance diffusion. So you can think of what layer 1, this middle upsampler, is doing is it's actually taking the decoded audio that was generated from layer 2 as its init audio here. And so there's an init strength for the upsamplers. There's also number of steps, which I haven't provided as a changeable parameter, but if you've seen text to image models, number of steps is something that's often provided. So that's where these are. So this base layer here, level 2, we're doing 250 steps. We have an embed. Oh, you can also change embedding strength. So the embedding strength refers to how strongly you want the model to listen to the context audio. Here, it can be any number. I've chosen 4. I've found 4 to be good, and I've kind of just put it here in this YAML file, and I just kind of keep it there. There's also a checkpoint location. So if you ever do train your own models or train your own dance diffusion model, this is where you would change the checkpoint location to refer to the model that you've trained yourself or fine-tuned yourself. Yeah, you can see there's init strengths. There's no init strength for the bottom layer here because I provided init strength as a parameter to change, because I find that I change that quite often. I don't really mess with the intermediate upsampler init strength too much. I kind of found parameters that I like, and I just kind of keep it this way. You can mess around with it if you want to change how the upsampler acts. But then the dance diffusion up here, there is an init strength here that I do actually end up messing with quite a bit. And I'll show you what this does and changes the generation so that you can kind of understand what's happening with dance diffusion and how much it changes from the layers below it. And this is also a great way to kind of show off how the noise style works. So you can kind of get a better idea for what's actually happening here. There's other things here. There's X fade samples and X fade style. Basically, this is just that when you generate at the dance diffusion level, I actually generate a little bit before every clip, and then I fade them into each other just so everything's a little bit smoother. This is number of samples that you fade with. You can increase this to kind of make things a little bit smoother if you're finding things are a little bit jumpy or a little bit cut up or something like that. But changing the init strength also does that. So let me change this. This is the thing that I mess with the most in here. So right now we have an init strength of 0.3, which means that dance diffusion only does the last 70% of the diffusion process and takes the initial 30% from the layer below it, which means that it's staying pretty true to what's being generated at the lower levels. If we change this to, let's say, something like 0.1, dance diffusion is going to do a lot more imagining, and it's going to rely less on what has come before it. So this should save. Yep. And so now the init strength is 0.1. And I'm going to change this seed back to the hi-hat seed. I have a feeling that's going to show what I want a little bit better. To showcase this walk parameter, what we're going to do instead is I'm going to change it to constant. So what it's going to do is it's going to use the dance diffusion is going to use the same noise every single time it generates a new sample. So let's see what that sounds like. Okay, so again, what we changed here is we changed the init strength of dance diffusion, which means that dance diffusion is going to use less information from the generations below it when generating at the top level. So dance diffusion has more imagination or control over generating new samples. Now, dance diffusion, again, is an unconditional model. So if it's not using the information from the lower generations, what it's really relying on is it's relying on those noise seeds to determine what it's going to generate. So let's listen here. So what it sounds like to me, and maybe you picked up on it as well, is it sounds like every 2 seconds, it sounds like it almost restarts. It doesn't sound like a cohesive kind of long form song anymore or clip anymore. It just sounds like it does a clip and then 2 seconds later, it does another clip. And now That is, of course, because the noise style, which is constant, Dance Diffusion is going to use the same noise every single time it generates a new sample, which again is every 2.229 seconds. You can hear how it's pretty similar every single time through. Now, it's because obviously we have the init strength down pretty low. Let's change this back to walk, and then I'm going to change the DD noise step size all the way up to 0.5. So now we're taking larger steps every single time, so the noise is getting further and further away from where it started. So this should give you a good idea for what this parameter noise step size is actually doing. Okay, sweet. So let's listen and see what that did. Again, what I'm going to be listening for here is because the init strength is so low, we're hearing more of what Dance Diffusion is doing on the top level. And because we raised that noise step size, I would expect each window to move a little quicker, not repeat like it was when we made the noise constant. Yeah, you hear how that little triplet hi-hat that we're used to hearing at the beginning, that goes away completely on the second window. You can hear it when it comes in. There. You hear that? Slowed down and actually went into a different area. It kind of sounded like a different genre almost. Slowed down a little bit. Last thing I'm going to show you is just the token multiplier and what that changes really briefly. I'm just going to change this token multiplier down from 4 to 2. This should speed up every single one of our Dance Diffusion windows, but it's going to mean that we're going to actually create 2 different windows at the bottom. We'll go back to this chart here so you can see. We were at token multiplier 4 before with using only the middle upsampler. So our windows were 2.229. Now we're going to be generating 4.458 seconds at the bottom layer. So we're going to have to generate 2 of them to get to 8 seconds, which is the length of our initial audio. And then the middle upsampler is going to be, which is our top layer before it goes to Dance Diffusion, is going to be generating 1.115 seconds of audio, which means we'll probably speed up our Dance Diffusion speed. But since we're generating 2 windows down here, that transforms into 8 windows at the top layer. So it should be 8 windows at roughly 30 seconds, I would imagine. So it'll be roughly around the same amount of time, but you'll hear those Dance Diffusion windows happening much quicker. And I'll actually change the noise style back to constant, or I'll change it to random so you can hear what random sounds like. Oh, sorry, that's the wrong one down here. So now every 1.115 seconds, we're going to generate a new random noise for Dance Diffusion. And because our init strength is so low, you should be able to hear it change every roughly 1 second pretty good. If this was back up at 0.3, it might be less obvious. But yeah, just to kind of showcase what's actually happening. Okay, let's listen to that. Yeah, so you can see every second it's basically changing genres. So sounds like a radio changing or something like that. So anyway, that's what happens when you make the window sizes smaller. Obviously, it has less to work with, and so it stays less consistent second by second. The way you could combat that, obviously, is to make the noise style constant, or you go down to region and walk and kind of mess around with this. But the number one thing that would change that is honestly changing the init strength here, maybe back up to like 0.3 or 0.4 or something like that, even if you're dealing with smaller window sizes. And it will use more information that was generated at the lower levels. In fact, I'll actually show you what was generated at the lowest level so you can understand how different it sounds. So you can see our first window, because we have 2 windows at this level now, actually sounded a lot like our beginning. and then midway through it actually changes a little bit. Yeah, that's basically just because we're doing 2 windows now, and there's different ways that you can interact with that, obviously, with the context audio that's being input to the lowest level, and then also the noise dial that's being used to generate there in conjunction with the init strength. So yeah, that's pretty much the end of the tutorial. I just kind of wanted to show you a little bit of how you can use this tool to generate new music. I hope all the parameters kind of make a little bit more sense now, how they work together and how they interact. Yeah, I'll make another video hopefully at some point going a little bit more in depth to what's going on at the bottom layer and with the noise styles here, but and this update lowest context parameter here. But for the most part, if you use the parameters that are given to you, the defaults in this notebook, and keep the token multiplier at 4 and this init strength up more at 0.3, you'll generally get what we got at the beginning, especially if your clips are smaller, around 8 seconds or so. If you make longer clips, then you're gonna have to deal with the bottom layer changing and using more windows. So that's another thing. Maybe I'll do another update about that at some point. But yeah, I hope this was helpful. I hope you make cool stuff with it. Thanks for watching, and yeah, have fun. Please post anything that you make. I'd love to hear it.